Hi everyone, I'm Jamie Zhou from It Storage team. So our founder Zhou was supposed to be here, but I'm here on behalf of him. So yeah, it's like nice to be here introducing Web3 Access Protocol. So first, let me briefly introduce our team. We are a team of about 10 members, and our founder Zhou, he's an active blockchain developer and also an Ethereum ecosystem contributor. So he authored or co-authored several EIPs, including EIP 4804. And before this, he also worked at Facebook and Google as a software engineer. And all other team members, they are very experienced in this field for years. So after 2 years of research and development, we received 2 grants from the Ethereum Foundation. So one is on data availability sampling research, and one is on ETH storage, which is a storage solution that I will introduce later in this talk. And also, we just won the first place at Conspol Demo this year. So what is Web3 Access Protocol? So it's a HTTP-like URL, but instead of locating centralized resources hosted by server, it's locating decentralized data hosted by smart contract. So it's also defined as ERC 4804, and which was developed by the storage team as well. And this one was finalized this February. Then why do we need Web3 Access Protocol? So the original motivation for us was that more and more NFTs are coming to be fully on-chain. And to name a few, cyber brokers, nouns, moonbirds, and art blocks, and there are more NFTs are coming fully on-chain. So when the NFTs are fully on-chain, there are more features and they can play with, and they can do a lot of more things than just being a simple image. And also NFT owners, they don't only own the token URL with the token ID on smart contract, but they also own the corresponding data that will never disappear on chain. So cyber brokers, they spent about $2 million to store their data on Ethereum, but they still use third party like IPFS to render image, because there's no other way to render image directly from the network. So what we are trying to do is to allow users to browse content directly without any third party like DNS, HTTP server, or IPFS. And how do we use Web3 Access Protocol then? It actually inherits most features of HTTP. So instead of an authority, it has a decentralized authority, which is a contract by address or name. And there's also a way to call the contract, which is called data, and a format to return data, to display the data. So it can be any type of files, like JSON file, JavaScript, or a native web address, pictures. So any type of files can be displayed using this Web3 Access Protocol. And there are a lot of examples, and one good example is our website itself. So when you go web3url.io, our website, it's actually hosted using Web3 Access Protocol already, and it's running on top of Ethereum. So how do we access EVM with Web3 Access Protocol? So there are 3 ways. So one is gateway. The current gateway for Ethereum is now w3eth.io. So if you see the examples on the screen, the link, you add Web3 URL contract as the subdomain of the gateway. And our gateway now supports lots of major blockchains like Arbitrum, Optimism, BNB Chain, Polygon, Avalanche, Scroll. So we are adding more blockchains on our list. So if you want to add your chain or want to do some kind of cooperation, you can contact us. And the second access way is Chrome extension. So I put the link, GitHub link right there. So it has all the details like how to install, how to use this extension. So once you install this extension, in the URL bar, you just type in Web3 keyword, and Web3 URL prefix will just be automatically filled, and you can type the rest. And the extension will interpret all Web3 URLs in its own service worker and send requests to Ethereum JSON RPC service like MetaMask. And the third way is a native browser support. So the current native browser is actually developed by our community members. And we are working on more support from native browsers like Chrome, Firefox, or Opera. So there can be a lot of applications. One good example is on on-chain NFTs like cyber brokers. So they upload all data on-chain and compose them using smart contract. And we deploy a contract to render the data and register like cyberbrokers-meta.eth and point to the render contract that we deployed. So we've done some experiments using Web3 Access Protocol, and one example is Vitalik's blog. So we uploaded the whole blog to Arbitrum Nova, and this contains about like 40 megabytes of content, and it costs 0.13 Ethereum. So using Web3 Access Protocol, the blog content on decentralized network can be rendered directly without any third-party trust. So this actually got lots of feedback and comments. So the discussion is ongoing, so you are all welcome to join our discussion. And we are doing all other experiments as well, like for example, Stanford Blockchain Review upload and others, so you can check out more details. And there are more applications as well. So one big case is dynamic website with multi-user interactions. So for example, like decentralized Blogger, decentralized Dropbox, email, GitHub, even Craigslist, or anything going on in Web 2 can now benefit from Web3 Access Protocol. So this list on the screen is already live on our testnet, so you can visit our website and check out those. So it's good that we can do a lot of things that we couldn't do before using Web3 Access Protocol. But there are still limitations in infrastructure level. So the critical issue here is that storage cost on Ethereum is super expensive. So maybe using Arbitrum Nova with DAC might lower the cost a little bit down, like we did with Vitalik's blog, but we still need a better on-chain storage solution. So that's why we developed Ether storage. So with Ether storage, the major goal is to reuse Ethereum security properties and extend Ethereum storage capabilities. So key idea here is that building a storage-specific rollup versus EVM-specific rollup. So we try to reduce Ethereum storage costs by 1,000 times lower and scale storage capacity to petabyte level. But we still reuse Ethereum mainnet security and still pay storage fee in Ethereum. And this is permissionless as well. So any node with the minimum required storage capacity, which is 4 terabyte, they can join the network. So you might ask, what's the difference between Ether storage and EVM-specific rollups? So the biggest difference is the incentives to give the storage providers. So it's in Ethereum, and it's a motive for them to store data. And skipping all the 6 rows, and in the last row, if you see, this storage proof allows users to verify on layer 1 that there's a large amount of replicas, about like 100, that store data of chain in the layer 2 network. So there's no such enforcement in the current event rollups yet. And then another frequently asked question is that what's the difference between the storage and all other decentralized storage solutions like Filecoin, Arweave? So there are 2 major differences. One is that either storage is designed for hot dynamic data with high value on top of Ethereum. So Filecoin, Arweave, those are more like cold storage with only like static data. And second difference is that Ether storage is highly incorporated into Ethereum ecosystem. So existing Ethereum tools like MetaMask, Solidity, Waffle, those things can operate Ether storage data. So to achieve these goals, we need lots of technology innovations. First, we need to solve decentralized data upload problem with Ethereum's data availability, or EIP 4844 and Dank sharding. So in this specific area, we are working with the Ethereum Foundation as we received the grant for this area. So we are trying to make it happen as fast as it can. And the second is after the data is on chain, we need to ensure to persist data with the required redundancy so that we make sure that data is secure on network. So that's exactly what Ether storage is doing. And lastly, we need to retrieve data in a decentralized manner, and that's why we built this Web3 access protocol. So now with all these possibilities, it's like we can now create a better future Web3 environment. So with Ether storage, we can scale dramatically and also lower the cost. And with Web3 access protocol, we can retrieve data in a fully decentralized way. So the whole layers are decentralized. So here's our roadmap. So we are actively working on EIP 4844 DevNet with Ethereum developers. And we recently launched our libraries to support new OP codes enabled by EIP 4844. And we are also building a snark prover and verification contract. So when the EIP 4844 is ready and testnet is ready, we'll be able to deploy the whole system into the Ethereum network. So we believe that we can now have lots of interesting and different applications using these technologies. So here's our website. So for Web3 Access Protocol and Ether storage for HTTP version and also Web3 Access Protocol version. So please join our community on Twitter and also Discord because the discussion is now really active, and contact us for more questions through this email. So thank you for your attention, and I would be happy to answer any of your questions off the stage. I'll be around. So yeah, thank you.